Topic is Quantum Chemistry by Veerabhadraya Demaya. Contact 96638828 for further information. Now, in 1913, Niels Bohr proposed a theory for the hydrogen atom based on the quantum theory that energy is transferred only in certain well-defined quantities. Electrons should move around the nucleus, but only in prescribed orbitals, which are called principal orbitals K, L, M, N, O, P, etc. This is the prescribed orbital. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, etc. These are called the energy levels, which are principal energy levels. When the electrons, when jumping from one orbit to another with lower energy in light quantum is emitted. As per the discussion about the modern chemistry or the quantum chemistry, my dear friends, the electrons sometimes it acquires energy. The photoelectric effect also we are discussing about the acquiring of energy, and it is ejected from the metal ions, metal surface. The energized electron is called a photon, my dear friends. So just you can recollect the memory. The electron here, the electron which is giving out the energy in the form of a photon. That is, a photon is energized particle of an electron. Now, Bohr's theory explains about the visible light transitions of the hydrogen atom. This is the important concept here. These are the energy levels of hydrogen, and N is equal to 1, N is equal to 2, N is equal to 3, and N is equal to 4 are the energy levels of hydrogen. Bohr's hydrogen atom is explained so many things here in this study. Niels Bohr introduced the atomic hydrogen model in 1913. He described it is a positively charged nucleus comprised of protons and neutrons surrounded by a negatively charged electron cloud. The atom is held together by electrostatic forces between the positive nucleus and the negative surroundings. This is all about the Bohr's atomic theory, that is Bohr's hydrogen atom. This is electron, which this electron is around the nucleus in the orbit. This is the nucleus which is positively charged. The electron is able to revolve in certain stable orbits around the nucleus without radiating energy, contrary to what classical electromagnetism suggests. These stable orbits are called stationary orbits, which are K, L, M. These are the principal orbits. They are also called as principal orbits or stationary orbits. Attained at a certain distance, which is having their own discrete distances from the nucleus, the electron cannot have any other orbit in between the discrete ones. The Bohr model of an atom was based upon Planck's quantum theory of radiation. Let us discuss about the Planck's quantum theory of radiation in forthcoming modern physics classes. The stationary orbits are attained at distances for which the angular momentum of revolving electron is an integral multiple of reduced Planck's constant. When n is equal to 1, 2, 3, which are called the principal quantum number, h is equal to h by 2f, 2 pi. The lowest value of n is 1. This gives the smallest possible orbital radius, which is 0.0529 nanometer, known as Bohr's radius. Once an electron is this lowest orbit, it can get no closer to the proton. Starting from the angular momentum quantum rule, Bohr was able to calculate the energies of the allowed orbits of the hydrogen atom and other hydrogen-like atoms and ions. These orbits are associated with definite energies and are also called energy shells or energy levels, which are principal orbital energy levels K, L, M, N, etc. And in these orbits, the electron's acceleration does not result in radiation and energy loss. The Bohr model of an atom was based upon Planck's quantum theory of radiation. Well, friends, electrons can only gain and lose energy by jumping from one allowed orbit to another, absorbing or emitting electromagnetic radiation with a frequency nu determined by energy difference of the levels according to Planck's relation E is equal to h nu. In the Planck's quantum theory of radiation, Planck tells about the relativity between energy and the particle. That is, Planck's Albert Einstein also explains about the mass-energy relation. These are the very important concepts by Planck and Albert Einstein. E is equal to mc square and E is equal to h nu. There are very close relation. Delta E is equal to E2 minus E1, the difference between from one energy level to another energy level, which is equal to h nu, where h is the Planck's constant. Well, friends, the first energy level can hold a maximum of 2 electrons. For example, hydrogen, atomic number 1 and mass number 1 and 1 electron. In case of helium, atomic number 2 and mass number 4, 2 protons and 2 neutrons, that is 2 electrons. In case of lithium, atomic number 3, mass number 6, 3 protons and 3 neutrons along with 3 electrons. Similarly, neon, atomic number 10, mass number 20, 10 protons and 10 neutrons and 10 electrons. During the process of Bohr's model, we have to discuss so many things in the forthcoming classes. Electronic distribution of various orbits of energy levels can be calculated by the formula 2n square. Here, n denotes the number of orbits. The number of electrons in k shell than the first orbit can be calculated when k is equal to 1. Use 2n square formula, substituting the value of n. When n is equal to 1, you will get the maximum number of electrons in first orbit is only 2. Suppose in the next principal orbital, the next energy level, next higher energy level, L is equal to 2. Similarly, using the same formula 2n square, then substituting the value of n, that is equivalent to the maximum number of electrons in the orbit is 8. Now, here the typing mistakes is there. This is the first orbit, this is the second orbit, this is the third orbit, and this is the fourth orbit. I am apologizing you for typing mistake. This is very important. Please correct it as first orbit, second orbit, third orbit and the fourth orbit. The distribution of electrons taking place is K shell is 2, L shell is 8, M shell is 8 and N shell is 32. This is 18. This is 18. Again typing mistake. I'm very sorry. Now, so another important thing is that, my dear friends, electronic configuration using a principal total number of electrons in the principal energy levels, which is K, L, M, N, that is 2, 8, 32 and that 18 and 32. It's very important in the distribution of electrons. Aufbau principle. The Aufbau principle from the German Aufbau Prinzip, also called the Aufbau rule, states that in the ground state of an atom or ion, electrons fill atomic orbitals of the lowest available energy levels before occupying the highest energy levels. For example, 1s subshell is filled before the 2s subshell is occupied. These electrons occupy the first lowest available energy levels before occupying the higher energy levels. First 1s, then after filling up 1s, it should go to the 2s, and after filling 2s, it will go to 2p and 3s, and after filling 3s, again it will go to 3p and 4s, and 3d, 4p, 5s, and so on. Yes, friends, this is please take it as a home assignment for the practice purpose. Write the electronic distribution of various orbits for the following elements. I have arranged 1 to 10 for your kind information. Using of principle, you please write down the distribution of electrons is nothing but the electronic configuration for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Up to that time, you can consider increasing order systematically. Hydrogen 1, helium 2, lithium 3, beryllium 4, 5, 6, 7, 8, 9, 10. You can write down another important electronic configuration of the following elements like sodium, chlorine, potassium, calcium, magnesium, iron, aluminium. Use the above principles. Quantum numbers allows to define the location of the electron within the atomic structure. Within each shell, we find subshells that have different shapes depending on their energy level and thus can fit a different number of electrons. They are named after the electron letters S, P, D, F, and so on. These subshells are second quantum number and are numerically defined as follow. Letter L is equal to level L. S is 0, P is 1, D is equal to 2, and F is equal to 3. Calculate the number of orbitals by the equation 2L plus 1. Thus, in the S shell you will have 2 electrons, P shell you will have 6 electrons, D shell you will have 10 electrons, F shell you will have 14 electrons, which will give the distribution of electrons in the hybridization of orbitals, which is S, B, D, F orbitals. Like, share and subscribe. Thank you. Hello friends, VVSM Academy welcomes you to the subject chemistry today. Topic is electronic configuration by Veerabhadraya Demaya. Contact 9663828428. Well friends, we will have a discussion about the Niels Bohr's proposed theory for the hydrogen atom.